About conditional and biconditional statements. So first off, a conditional statement just means that if P is true, then Q must be true. Okay? So that means P represents your hypothesis, and Q represents the conclusion. So with the conditional, P then Q means if P is true, then Q is true. Okay? So, for example, if the measure of angle A equals 30, then angle A is an acute angle. So the measure of angle A equaling 30, that's your P. That's your hypothesis. Angle A is acute. That right there would be your Q, or your conclusion. Okay? So if we were told to write this statement, an obtuse triangle has exactly one obtuse angle, and we wanted to write that as a conditional statement, then all we would do is we would say, if a triangle is obtuse, then it has exactly one obtuse angle. So this would be your conditional statement. If a triangle is obtuse, then it has exactly one obtuse angle. Now we'd want to question, is this true or false? Well, we know this is true because for it to be an obtuse triangle, it has to have one obtuse angle, and no triangle can have more than one obtuse angle because the triangle's angle measures have to add up to 180. Another example, given this Venn diagram, we could say, if it is a blue jay, then it is a bird because all blue jays are birds. So, it's a blue jay, that would be your hypothesis. It's a bird, that would be your conclusion. Okay? So, one more example. Two angles that are complementary are acute. That means if two angles are complementary, then they are acute. So if, which we know this is true because if two angles are complementary, they both add up to 90. Acute angles are less than 90. No complementary angles can be more than 90. So two angles are complementary, that's going to be your P. That's your hypothesis. Then they are acute. That right there is your Q, or your conclusion. Okay? So, we're going to do one more. Number 5 would just be, if it is a bird, then it has wings. Number 6, if I buy groceries, then I buy them at Target, is what that's saying. Okay? Okay? So, if it's true or false, you can look at it and state its validity. If I buy groceries, I buy them only at Target. Well, that's only going to be true if you only shop at Target. Somebody who shops at, say, Walmart, that might not be true. This statement right here, if I buy groceries, you don't have to go to Target. Okay? So that one could be true, but it easily could not be true. Now, let's look at this one. If a person owns a dog, then they are a pet owner. Well, first, we know our hypothesis is if a person owns a dog. Okay? Your conclusion is that then they are a pet owner. Is this true? Yeah. We cannot come up with a counterexample of this because if they own a dog, they're a pet owner. They could own something else and still be a pet owner, but we know that if they own a dog, they're a pet owner. And the next one, if two lines intersect, then they are perpendicular. Well, if two lines intersect, this right here, that would be your hypothesis. Then they are perpendicular. This is your conclusion. Okay? Well, couldn't two lines intersect and not be perpendicular? If you say had this, those angles aren't perpendicular. So that right there would be a counterexample. They intersect, but they're not perpendicular because those are not right angles and they're not congruent. Okay, so this one would be false. Now, a biconditional just means that it works both ways. It means if P, then Q, and if Q, then P. Okay? So you should be able to read that either way. Now, the converse means that if Q is true, then P must be true. Okay? So on a biconditional, you would say your hypothesis is true if and only if your conclusion is true. That means your hypothesis is true. If your hypothesis is true, then your conclusion, and if your conclusion, then your hypothesis. So this means the conditional and the converse are both true. Okay? The converse means if the conclusion is true, then the hypothesis is true. Okay? So it's just backwards. If the conclusion, then the hypothesis. So for number 12, the conditional would just mean, let me delete that one. The conditional would, the converse first. If I said, this is my P, if it's a right angle, this is my Q, angle A is 90. So then the converse would be, if the measure of angle A equals 90, so if that's 90 degrees, then angle A is a right angle. Okay? So, if it's equals to 90, then the angle would equal, let me fix that angle marking, then the angle is a right angle. Okay? So, is this true? Yes. So from there, we could do a biconditional, and a biconditional says, if, since measure of angle A, when measure of angle A equals 90, then angle A is a right angle, and the measure of angle, if the measure of angle A is a right angle, then it's 90, then the biconditional just says, angle A is a right angle if and only if, which I can just write as IFF, again that means if and only if the measure of angle A equals 90 degrees. Okay? That means it works backwards and forwards. So this right there just means if and only if. Okay? So that means it works backwards and it works forwards. Okay? So let's try another example. This time, we want to look at the converse, inverse, and contrapositive. Well, we haven't talked about contrapositive yet, but first let's go ahead and write the converse. So if it's raining, that's going to be your hypothesis. Then it's cloudy, that's your conclusion. So this right here is an example of the conditional. Okay? Now, your converse would be, if it is cloudy, then it is raining. Okay? If it is cloudy, then it is raining. Now, is this a true statement? No. because if it's cloudy, it could just be overcast. So that one's false. Since this is false, there is no biconditional because the biconditional would be false. The biconditional can only work if the converse and conditional are true. Now the inverse would be the opposite of P implies the opposite of Q. Okay? So this little squiggle line right here just means negation. Okay? So that just means the negation of P implies the negation of Q. So in this scenario, it would be, if it is not raining, it is not raining, then it is not cloudy. Okay, so that would be your inverse. The opposite of P implies the opposite of Q. Now, we can see that if it's not raining, then it's not cloudy. That's saying the same thing, that if it is raining, then it is cloudy. Your converse and your inverse are always going to be the same. Either they're both true or they're both false. So this one right here is also false. These will always be the same for converse and inverse. Okay? Now, the last one we're going to learn is contrapositive. So the contrapositive is, if it's not Q, implies not P. Okay? So in this situation, it's basically completely backwards and inverted from your conditional statement. Okay? So in this example, we would say, if it's not cloudy, so if it is not cloudy, then it is not raining. Okay? If it is not cloudy, then it is not raining. That's your contrapositive. Now this one, we know would be true, because you have to have clouds for rain. Well, if it's raining, then it's cloudy. That one's also true. So again, your conditional and your contrapositive always have the same truth values as well. Okay? Now, your conditional and your converse are not always the same, and your inverse and your contrapositive are not always the same, but the converse and inverse are the same, and the conditional and the contrapositive are the same. You can also find more of that on page 83 in your textbook. We'll give you more on those truth tables. Good luck.